Section 10.2 is graphing cube root functions. Your learning target is that you will be able to graph cube root functions and compare cube root functions using an average rate of change. So your cube root function kind of has the half of it that looks like your square root function, but then it has another half that looks like another half of parabola going the opposite direction. So this is your parent function of a cube root function, and it's the cube root of x. The domain and range are both going to be all real numbers for your cube root functions. So all of our transformations that we've been learning, again, apply here in this section with cube root functions. So we're going to graph this and compare it to the parent function. So this plus 6 on the outside is going to give us a translation up 6. And then we're going to go ahead and make our table. And your rules for this one kind of apply as far as the starting point again. So this is like your H and your K. And so we have that point of inflection here. So again, cube root functions don't have a vertex, but they have that point of inflection where the graph kind of changes directions. So then I'm going to go ahead and plug in 1 as well as -1 here. And we're actually also going to jump to the next perfect cube, which is going to be 8 or -8. So if you have a calculator, you can use -2 or -3 to calculate some more values. So we're going to start, let's start by plugging in 1. So we have the cube root of 1 plus 6. So the cube root of 1 is 1, and 1 plus 6 is 7. So if now I plug in my -1, my cube root of -1 is -1, and -1 plus 6 is going to give me 5. So now plugging in +8, the cube root of +8 is 2. 2 plus 6 is 8. And the cube root of -8 is -2. And -2 plus 6 is 4. So we're going to go ahead and plot these. So we have 0, 6, -1, -5, and -8, 4, and then 1, 7, and 8, 8. So when you graph this, you have half a sideways parabola going this way, and then half a sideways parabola going this way. So here's your graph. Okay, so again, we're making the comparison to the parent function. So first we have a negative here, which is going to be a reflection in the x-axis. Then we have this +4 on the inside. When it's on the inside, you do the opposite. So this is a translation left 4. So again, using kind of like those same properties as our H and our K to find like our vertex of our quadratic, we can use that to find the point of inflection of our cubic function. So that means we have -4, 0 as that point of inflection by doing the opposite of what's inside the radical, and then we're not adding anything on the outside. So then I'm also going to do -5 and -3. And we can also do 4 and negative 12 because that would give us a perfect cube in here. Again, but if you have a calculator, you can pick different values. So when we plug in negative 3 plus 4 gives us 1. The cube root of 1 is 1. This is like multiplying by negative 1. So 1 times negative 1 is negative 1. And negative 1 Okay, so first we're going to plug in negative 3. So negative 3 plus 4 is 1. The cube root of 1 is 1. And then this is going to be like multiplying by a negative 1. So that's going to give us negative 1 here. When we plug in positive 4 plus 4 is 8. The cube root of 8 is 2. And then 2 times negative 1 is negative 2. When we plug in negative 5 plus 4 is negative 1. The cube root of negative 1 is negative 1, and then negative 1 times negative 1 is positive 1. And I'm going to plug in 12 just so we can kind of see where the graph goes, but it's not going to fit on our coordinate plane. But negative 12 plus 4 is negative 8. The cube root of negative 8 is negative 2, and negative 2 times negative 1 is positive 2. So here I have 1/2 and then my other half of my cubic function. Okay, so now we're looking at when we have multiple transformations. So our first 3 here is going to give us a vertical stretch. And here you do the opposite of the +1. So this is going to be a translation, left 1. And then our other translation comes from this number here, which is going to be down 2. So now working on our graph, again, you can use your properties of HK to find the point of inflection, which is going to be at -1, -2. And we can plug in -2 and 0 will give us perfect cubes, as well as 7 and -9. So when we plug in 0, 0 plus 1 is 1. The cube root of 1 is 1. 1 times 3 is 3, and 3 minus 2 is 1. When we plug in 7, we get 4. When you plug in -2 plus 1 is -1. The cube root of -1 is -1. -1 times 3 is -3, and -3 minus 2 is -5. And when we plug in -9, we get -8. So then you can plot your points and draw your graph, which will look like this.